Hi, welcome to the next part of the self-paced Unit 8 lesson. This is going to be the negative rule, 824. It says day 1 because it is possible that you will need more than one day to practice and work through these examples and rules. That, of course, is up to you. Before you begin, I would like you to pause this video, and then I would like you to work on each one of these problems as a warm-up, and then come back and listen to the explanation I have for you. Okay, so hopefully you were able to try each one of these, and let's see if your work is similar to mine. This rule right here is the power rule only. When we do the power rule, we're going to raise each individual exponent to the exponent, the base, or the exponent. Yeah. So we're going to have x to the third raised to the power of 2, and then we're going to have y squared raised to the power of 2. The rule for the power rule is that you keep the bases and you multiply the exponents. So when we do this, we would end up with x to the 6th, y to the 4th. Moving on, in this example, we have constants, and we also have the product rule. Now, as I was watching people go through their formatives and their summatives, the constant rule is the thing that was most often not done correctly. So let's go through this really deeply. The 3 and the 4 are not bases, they're not exponents, they're just constants. Why? Because they don't have a power associated with them. So they are just using the rule of multiplication. So you are going to be taking them out, and they are just going to be multiplied by each other. Please do not forget to do that. The next thing we're going to do is we have our x's, so I'm going to group them together. I have x squared times x squared, and then last is z to the 0. So in addition to the constants and the products, you also have the 0 rule. 3 times 4 is going to be 12. The product rule, when you work on the product rule, you add your exponents. Keep the base. So this becomes x to the power of 4. And with the 0 rule, everything becomes 1. So then that is times 1, and your answer would be 12x to the power of 4. Moving on, you have a product rule, and then you have a quotient rule here. The quotient rule, you subtract. Okay, so let's take a look and see what we're going to end up doing. The first thing I want to do is the idea of the product rule on the numerator. So I'm going to combine the two of them together. I'm going to have x squared times x to the 4th, and then I just have a 2, and that's going to all stay over xy cubed. Okay, so we're going to have x, 2 plus 4 is 6, and then we're going to just keep our 2 outside here. Then we end up with xy cubed. So I'm going to have 2 over 1. I'm going to have x to the power of 6 over x, and I'm just having y to the 3rd over 1. This becomes x to the power of 5. So when I combine everything together, I'm going to write it up top here. I'm going to have 2x to the 5th and y to the 3rd, and that is your answer. If you are not comfortable with any of these rules, I would really encourage you to pause and go back and review. Take a second to look at your learning targets. Understand that the 2 in pink are new ones. I understand that exponents cannot be negative numbers. I can apply the rule of exponents to negatives. Here is your to-do list. It should be downloaded. One thing that we need to understand is that in the rule of dealing with exponents, it is imperative that you understand that negative exponents are considered not in the most simplified form, and they are never, ever, ever allowed. So that's something that you're going to have to get used to, and we'll talk about that. Let's take a look at the evolution of the exponent going backwards, all right? So when we head down our list here, we have x to the power of 3, or 4 to the power of 3. That's 4 times 4 times 4, which gives you 64. We are getting rid of an exponent. We are dividing by the power of 4, which gives us 4 times 4. Okay, and then that gives us 16. Again, we're coming here, we're dividing one more time. That just gives us 4. Dividing one more time, 4 divided by 4, as you know, is 1. That's why everything raised to the power of 0 is 1. We're still dividing by 4. So what do we end up with? We end up with 4 to the negative 1 is 1 over 4. Okay, now we're still dividing by 4. So if you're dividing by 4 again, that means you're actually multiplying by 1/4, right? The reciprocal, which is going to give you 1/16. And that's what 4 to the negative 2 is, 1/16. So if we break this down a little bit more, you can see that as we transition past our positive numbers right here, we end up with a fractional component that is our negative exponent, and then the power of that negative exponent applied to the base. Let's do a few of these. We cannot have a negative exponent. So what that should tell you is the first thing you want to do is have a fraction of 1, and you take the base, which is 2, you put it down here, okay? And then you raise the base to the exponent, but now it's positive, and simplify when necessary. Let's do it again. Here is our base, so we're going to do 1 over our base, raise it to the positive value of the exponent. You could simplify that further if you'd like, but you do not have to. X is our base, so it's 1 over x, and you would raise it to the power, which is just to the power of 1. It's just 1 over x. Okay, so we're going to do some problems here. I'm going to work through them. You're welcome to work through them with me. We have a common base. We also have the product rule. So we are going to add our exponents. So we have 6. 3 minus 5, because 5 is a negative number. What does that give us? That gives us 6 to the negative 2. We cannot have a negative exponent. So then we take 1 over the base and raise it to the positive power, equals 1 over 36. Let's do it again. We have the product rule, and then we have the power rule. And then, of course, we're going to apply our negatives. So let's do our product rule first. That's a 1. So we're going to have 2 to the power of 4, and that is raised to a negative 2. Now we're going to apply the power rule. So we're going to distribute this to our exponent right here. So we have 2 to the power of negative 8. Cannot have a negative exponent, so we have 1 over 2 to the power of 8. Moving on, we have the product rule. Let's see what happens after we do that. We have w to the negative 6, because we ended up with negative 3 minus 3, right? And then we have our negative rule. So we're going to have 1 over w to the power of 6. So this is a pretty complicated problem, and we're going to break it down, and we're going to see how we do. All right, so the first thing I want you to notice is on the very top, we're going to start out by, you need to simplify inside your parentheses first. Absolutely inside the parentheses first. You're going to simplify all of this first, and then you're going to apply this. So you need to try to remember that. I know it's hard, but you really need to try to remember that. So the first thing we're going to do is use the product rule, and we're going to apply it right here, okay? So I'm going to just start out, I'm going to keep my fraction. I'm going to have negative 3. And then inside, I'm going to end up with x to the power of 7, y to the power of 3, all squared. I'm going to write the rest of my fraction down. I'm just going to leave it like this because I have not simplified everything yet. Okay? So this was using the product rule. The next thing I'm going to do is I'm going to apply the power rule. So hopefully you see that I have the power right here. I'm going to apply that power rule next. The negative 3 is not part of that. So I'm going to have negative 3. I'm going to keep my fraction. Negative 3. And I'm going to apply this 2 to each one of these. So I'm going to have x to the power of 14, because with the power rule, you multiply. And then I'm going to have y to the power of 6. I'm going to write down the rest of my fraction. Okay, moving on. That looks like a 16. Let me erase that. Oopsie. I'm batting 1,000 here, you guys. Okay. It is a 10. Here we go. So the next thing that we're going to do is we're going to apply the quotient rule. And here is where I go through and I break everything down. I separate my stuff. Okay? So now I have 3 pieces. I have negative 3 over 12 times x to the power of 14 over 20. Oops. Over x to the power of 20. Then I have y to the power of 6 all over y to the power of 10. Okay, I'm going to go down. This is going to become 1/4, negative 1/4. I'm going to go down again. I have x to the power of 14 minus 20. I'm going to keep going. This is going to be x to the power of negative 6, which we know is going to be a problem. I'm going to keep going. I have y to the power of 6 minus 10. Keep going down. I have y to the power of negative 4. So I have applied my quotient rule. So the next thing I'm going to do now is I'm going to put it all back together. Actually, I'm not. I know that I have negative exponents. I have a negative exponent right here, and I have a negative exponent right here. So I'm going to work on those. First, the negative 1/4 doesn't matter. It's a number. It's a constant. We're just going to keep it with us. So I'm going to work on my negatives now. I still have negative 1/4, but I know I cannot have a negative exponent. So I put 1 over the base and raise it to the power of a positive exponent. I put 1 over the base and raise it to the power of a positive exponent. And now you have to put everything back together. So I have 1s straight across the top, and it's negative. Doesn't matter where you put the negative. I have 4. X to the power of 6, y to the power of 4. And there you go.